Hi and welcome to our next installation of naming hydrocarbons. Today we are going to expand on what we were looking at yesterday in class. So yesterday in class we were looking at alkanes, alkenes and alkynes and how to name those. Now what happens when we get some branching off that basic straight chain? So the train structure can have a main chain with then some branching off those. And there's a systematic naming system for those branches as well. And these are things you're just going to have to memorize and learn how to do them. And practice is what will make perfect. So the first thing we need to do is look at our number of carbons in our chain. Now remember, of course, our straight chain doesn't actually have to go, as the name suggests, straight across, but it can be where we can find the longest carbon chain. After we have done that, we need to look at where it branches off. And those branches will be called our alkyl groups. So if we have one methyl chain, so it's a CH3 off the side, it's a methyl group ending in a YL. And they're the same naming systems as we used to use a straight chain. So 2 groups is an ethyl group. And that's all you really need to know for the HSC course. But it continues on the same as what we had before. If there's a 3 carbon chain branching off the main chain, then it's a propyl group, a butyl group if there's 4, and so on. So let's have a look and see how do we go about naming these different kind of branching hydrocarbons. So the first thing we need to do, as I said before, is find and name our longest chain. Now we need to be careful with that because sometimes it doesn't always appear in a straight chain and it's not always as obvious. So we then give it its alkane name. Once we've done that, we then look at the branching group that comes off. And we always need to name it with its smallest number. So in the case of this example here, we have got a 1, 2, 3, 4, 5, 6, 7, 8 chain group. So we've got octane, and off here we have got a 1 carbon chain, so a methyl group here. Now how are we going to name this? We need to always look where it can be attached. We always name it from which carbon it is attached to. So we always want that also to be the smallest number. So we could have it as 1, 2, 3 octane, or it could be a 1, 2, 3, 4, 5, 6. So obviously 3 smaller, we're going to name it from this end. So the first thing we do, octane. Second thing we do, look at what it is, the branching group is, and it's a methyl group, just a 1 carbon chain. And we notice that it is on the 3rd carbon. So because of that, we name it 3 for the 3rd carbon. Methyl, so that's the methyl group is attached to the 3rd carbon of the octane alkane. So it's 3 methyl octane. Notice there that it is one word. And it's important that we do have it as one word. So sometimes if you're doing your working out, that's fine. I would suggest rewriting it again, just making sure there's no gaps and so forth for any misunderstandings. Well, what happens if I have more than one branch? Well, again, similar things occur here. We again have to find our longest chain. So in this case here, we have got a 1, 2, 3 carbon chain going across there in the center. Even if we looked elsewhere, it's a 1, 2, 3 across here, or a 1, 2, 3 across here. Either way we look at it, it's a 3 chain carbon. So we are looking at a propane there. Now we need to look at where our branches are. We have got a 1 carbon chain branch off here and another 1 carbon chain branch off there. So we're looking at 2 methyl groups. So another part of the naming system is there. I've got 2 methyl groups, so we call that dimethyl. Di meaning 2. Tri then will be 3, and so on. So we have now got our 1, 2, 3 carbon chain, so our propane, and it is coming off the 2nd carbon chain, or sorry, the 2nd carbon in that chain, and we have got dimethyl. So with this one, we are going to have to look and think, all right, how are we going to name this? And it's going to be a 2,2-dimethyl propane. So let's have a look at another one. We always want to make sure we've got the lowest number. So have a look at this structure. and see if you can name it with the past two examples to help you. See how you go with this one. Okay, how did you go? Let's have a look at what you may have done. So again, we're looking for our longest carbon chain. We have got 1, 2, 3, 4, 5, 6, 7, which would indicate heptane. We have got a carbon or one carbon chain off here, another one carbon chain off here, and another carbon branching chain off there. Now they're all one carbon chains, so they're methyl groups. There are 3 of them, so there's trimethyl. Then we need to work out what number carbons they are sitting on. If we look from this side, we have got a 2, a 5, and a 6. Yet if we look from this side, we have got a 2, a 3, and a 6. So it's our lowest number. 236 is lower than our 256. So we're going to have to name it from this side. And that being the case, we're going to have our 2, 3, and 5 trimethyl. 1, 2, 3, 4, 5, 6, 7 heptane. Did you get it right? So 236 trimethyl heptane. So have a go now at this one. So just before you start, again, this is one of those ones where we need to look for the straightest chain. Here we've got 3, we've got 5, and we've got 2. Don't fall for the 5. Remember again that those base carbon chain do not have to go in a straight line. So in this case here, we've got that zigzag. So we've got a 6 carbon chain. With that 6 carbon chain is coming the name hexane. And then we have our 2 branching groups off here. Have a go, pause the video, come back and let's see how you went. Okay, so how did you go? We already talked before that we've got a hexane there. We have 2 ethyl groups this time, so we've got a diethyl, 2 ethyl groups, diethyl. And where are they located? So remember again, we're wanting them to be on the lowest. So we have 1, 2, 3 or 1, 2, 3, 4. So they're both going to go on that 3rd carbon chain there. So we're going to have 3, 3, so 3, 3 diethyl, and you've got your hexane. So let's try another one. So let's add to the next layer of complication. And what if we've got different branch lengths? What if we've got a methyl and an ethyl? What do we do then? So again, we need to use our lowest locator numbers used as we've done before. So what carbon chains are they on, and then the lowest. But if the numbers are the same, we have to use alphabetical order. So if I've got a methyl and an ethyl, our ethyl will come first. So let's have a look in this example. We again here have a carbon chain, and we can see it coming across through here, and it is a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. So we're looking at octane. Now we're having a look, and we have got off this carbon here, off the 3rd one from this side at least, we have got an ethyl group, and off this one here, which also if we were coming from that side it would be a 3rd as well, we've got a methyl group. So we need to look and go, all right, whichever direction I look at, my alcohol groups are attached to 3 and 6, so it doesn't really matter. And because of the alphabetical order rule, we're going to have to name our ethyl group first and give it the lowest carbon number. So here's our ethyl group here. So we're going to give it the lowest number, which is the 3. So it will be a 3 ethyl, 6 methyl, and then we've got our octane. So let's have another go at looking at some of these examples when they're with alkenes and alkynes. So the rules are really the same basic rules as for the alkanes, except here we've got a double and a triple bond to contend with. So we always need to look at where our double and triple bond is, and we're going to assign the double or the triple bond the lowest number, and then that takes priority over all our other alkyl groups. So the position of the double or the triple bond is paramount. Once we've got that done, then we go and name our alkyl groups, and with our alkyl groups they will be using that same naming process, using the direction that we're coming from for naming our double or triple bond. So let's have a look in this example here, and I might try and move me out of the way. Looking at this example here, we have got, let's have a look, 1, 2, 3, 4, 5, 6 carbon chain going across there. Now we have a double bond here, so that is a double bond attached here to the second carbon. So we're going to start from this end with our double bond being attached to the second carbon. So because it is the second carbon, it's going to be a hex-2-ene. Now we had this chat in class the other day about, do we do 2-hexene or do we do hex-2-ene? Both will always be accepted. The old way was 2-hexene, but apparently now it's been updated and we do hex-2-ene, and markers are apparently saying that they will accept either, but the more accepted version is the one with hex-2-ene. So let's do that as good common practice. So we've got hex-2-ene. Hex because it's a 6 carbon chain, 2 because the double bond is attached to the second carbon. So now let's have a look at where our branching groups are. We have got a branching group coming off here, which is the 1, 2, 3, 4, 5 carbon chain in both directions. And in both directions, we've got a methyl group. So we've got 2 methyl groups, so it's dimethyl. And we need to look at its placement. Its placement is on the 5th carbon then. So it's a 5,5 dimethyl hex-2-ene. Of course, there is that other way that I did speak about before. So let's have a look at an example. So what are we going to do with this one here? We have got to find, first of all, our longest chain. So find your longest chain, name that. No double bonds or triple bonds. So now we just want to look at what is our branching group off there and what number it's going to attach. Have a go at this. See how you go. Check with your answer next, and then we'll do a few more of these in class. See you soon. Bye.